guys. So enlargements and reductions. It's one of the topics of transformation geometry. It's not a very complex one. It's a fairly simple theory to grasp. So basically, enlargements, you have enlargements. It's if you take large in the word. So if you take that, that's making something bigger. And then you have reduction, so reduce, so you're making something smaller, and that's the two you work off on. They're both based on you make something bigger, you make something smaller, but you go off the original object and you go by sizes and proportion to the size, angles and distances. So if we take enlargements first, I have a square put in here. So basically, even if you just say, we're making it bigger, we're going to go off the point A for argument's sake. We're going to go off the point A. We're going to extend A through all the points to enlarge it, basically. That's in the name. So if you go through, extend all the lines. Think of it this way, guys. If you have an umbrella and you have it closed up and you're spreading it out, you're enlarging the top of the umbrella. That's one way of thinking of it. So say you wanted any old size. Just get a different pen. You wanted any old size. You just join up to where they originally were. And there you have your enlarged kind of version of the original object. And it's a pretty simple topic. You're keeping the distances and the angles. So that was right angle, that's right angle, that was right angle, that was right angle, that's right angle, that's right angle. You're keeping them the same, you're not changing them. You're not changing the ratio from this to this to this to this is the same as that. It's the same kind of concept. And that's really all there is to enlargements. Once you focus on your point and you go through all your points, you extend them to whatever distance you may want, you may have it in ratio, it's not too bad to kind of grasp and solve. And now reductions is same kind of theory but in reverse. So if you take the likes of the umbrella, what I was saying about earlier, if you take the umbrella, it's opened up umbrella. If you close it down, it's reducing. That's in the real life scenario. That's, you're not gonna have a lot of reducing stuff, but umbrella's one of them. So we're going off point A again. You want to reduce all that, but see, you already have the lines going through A anyway, because all you need is this line. And then say I wanted that length in diagonal, bring it down, bring it across, and that's my original. That's my new reduced shape from the original of that size. And that's really it. You're reducing it. Same with the umbrella. Even if you have the Russian doll scenario, you have a doll here. It's a terrible doll. But you have the bigger doll. And it's the same type. It's the same idea. You're enlarging. And then when you have the big dolls, you're reducing again. And that's another real world example. So really, enlargement and reduction is just making something bigger, making something smaller, and keeping the ratios of the original object the same as the other one. You keep it in proportion with the new object that you've made bigger or you've made smaller. And that's really is all there is to it. And feel free to Google some real life examples, because it's out there. So like Russian dolls, umbrellas, stuff like that, stuff that can expand, contract, that kind of thing.